Stars are massive balls of gas that shine brightly in the night sky. They are made mostly of hydrogen and helium. The closest star to Earth is the Sun, which provides light and heat necessary for life. Stars come in different sizes, colors, and temperatures. They are born, live for millions to billions of years, and then die, creating spectacular cosmic events. Understanding stars is important in astronomy. They help scientists learn about the universe. Stars are not just pretty lights in the sky. They are crucial to the existence of galaxies, planets, and even life itself. Their formation, life cycle, and eventual death are fascinating processes. Let's begin our journey into the life of stars. Star formation begins in vast, cold clouds of gas and dust, known as nebulae. Inside these clouds, tiny particles of dust and gas start to clump together due to gravity. This process takes millions of years. As the particles come together, they form a dense core. The core continues to attract more gas and dust. Eventually, it becomes so dense and hot that nuclear reactions start. This glowing core is the birth of a new star called a protostar. The protostar continues to gather material from the surrounding nebula. This phase can last for millions of years. When the temperature in the core becomes high enough, hydrogen atoms begin to fuse into helium. This fusion releases a huge amount of energy, marking the star's entry into the main sequence phase. Once in the main sequence phase, the star shines brightly. Larger stars burn their fuel quickly and have shorter lifespans, while smaller stars burn their fuel slowly and live much longer. Gravity plays a crucial role in star formation. It is the force that pulls particles of dust and gas together. Without gravity, stars would not form. In the vast, cold nebulae, gravity causes the particles to move closer to each other. As the particles clump together, their mutual gravitational attraction increases. This clumping continues until a dense core forms. The core's gravity becomes strong enough to pull in more gas and dust from the surrounding nebula. This accumulation of material causes the core to grow in mass and density. Eventually, the core becomes dense enough to begin nuclear fusion, the process that powers stars. Gravity also helps shape the star during its formation. As the core gathers more material, it starts to spin. This spinning causes the surrounding gas and dust to form a rotating disk. Planets and other celestial bodies can form from this disk, creating a solar system around the new star. Nuclear fusion is the process that powers stars. It occurs in the core of the star, where temperatures and pressures are incredibly high. During fusion, hydrogen atoms combine to form helium. This process releases a tremendous amount of energy in the form of light and heat. The fusion process starts when the temperature in the core reaches about 10 million degrees Celsius. At this temperature, hydrogen nuclei have enough energy to overcome their mutual repulsion and collide. When they collide, they fuse together to form helium. This fusion releases energy which heats the core even more. The energy produced by fusion creates pressure that counteracts the force of gravity. This balance keeps the star stable. As long as there is enough hydrogen in the core, the star will continue to shine brightly. When the hydrogen is depleted, the core contracts and heats up further, allowing the fusion of helium into heavier elements like carbon and oxygen. NASA has made significant contributions to our understanding of star formation. With advanced telescopes and space missions, NASA has provided valuable data on how stars are born and evolve. One of NASA's most important tools in this research is the Hubble Space Telescope. The Hubble Space Telescope has captured stunning images of nebulae, the birthplaces of stars. These images have allowed scientists to study the intricate details of star formation. Hubble's observations have revealed the presence of protostars and their surrounding disks of gas and dust. This information has been crucial in understanding the early stages of star formation. NASA's Spitzer Space Telescope has also contributed to our knowledge of star formation. Spitzer observes the universe in infrared light, which can penetrate the dust clouds where stars form. This capability has provided a clearer view of the processes occurring inside nebulae. NASA's missions, such as the Kepler Space Telescope and the James Webb Space Telescope, continue to enhance our understanding of star formation. NASA scientists have shared their insights into the fascinating process of star formation. Dr. Jennifer Wiseman, a senior astrophysicist at NASA, has emphasized the importance of studying star-forming regions. She explains that observing these regions helps scientists understand how stars and planetary systems develop. Dr. Wiseman highlights the role of advanced telescopes in this research. She notes that the Hubble Space Telescope has provided unprecedented views of star-forming nebulae. These observations have allowed scientists to identify the various stages of star formation and study the conditions necessary for star birth. Dr. Paul Hertz, director of the Astrophysics Division at NASA, has spoken about the significance of infrared observations. He explains that infrared telescopes, like Spitzer, can see through dust clouds that obscure visible light. This capability has provided valuable data on the early stages of star formation. Dr. Hertz emphasizes that infrared observations are crucial for understanding the birth of stars. Dr. Thomas Zurbuchen, Associate Administrator for NASA's Science Mission Directorate, has discussed the future of star formation research. He's excited about the potential of the James Webb Space Telescope. Dr. Zurbuchen believes that this telescope will revolutionize our understanding of star formation. Stars go through several stages during their life cycle. The first stage is the protostar stage. A protostar forms from a dense core in a nebula. It gathers material from the surrounding gas and dust. As the protostar's temperature and pressure increase, it begins nuclear fusion and becomes a main sequence star. The main sequence stage is the longest phase of a star's life. During this stage, the star fuses hydrogen into helium in its core. This process releases energy, which keeps the star shining. The star remains in the main sequence phase until it exhausts its hydrogen fuel. When the hydrogen in the core is depleted, the star enters the red giant phase. The core contracts and heats up, causing the outer layers to expand. The star becomes larger and cooler, turning red in color. In this phase, the star fuses helium into heavier elements like carbon and oxygen. Stars are essential to the universe. They are the building blocks of galaxies, which are vast collections of stars, gas and dust. Stars provide light and heat, making life possible on planets like Earth. Without stars, the universe would be dark and cold. Stars also play a crucial role in the formation of elements. During their life cycles, stars create elements through nuclear fusion. These elements, such as carbon, oxygen and iron, are essential for the formation of planets and life. When stars die, they release these elements into space, enriching the interstellar medium. Stars influence the structure and evolution of galaxies. Their gravitational pull affects the movement of gas and dust within galaxies. This movement can trigger the formation of new stars. Supernova explosions from dying stars can also trigger star formation by compressing nearby gas clouds. Stars are factories for creating elements. In their cores, stars fuse hydrogen into helium through nuclear fusion. This process releases energy and creates new elements. As stars evolve, they fuse helium into heavier elements like carbon, oxygen and iron. The fusion process in stars is responsible for creating most of the elements in the periodic table. Elements heavier than iron are created during supernova explosions. These explosions provide the necessary energy to fuse lighter elements into heavier ones. The elements formed in stars are dispersed into space when the stars die. These elements are essential for the formation of planets and life. For example, carbon is a key element in all known life forms. Oxygen is necessary for respiration, and iron is a crucial component of blood. Without stars, these elements would not exist, and life as we know it would be impossible. Stars are fundamental to the universe. They are the sources of light and heat, making life possible on planets. Stars create the elements necessary for the formation of planets and life. They also influence the structure and evolution of galaxies. NASA has played a crucial role in advancing our understanding of star formation. Through advanced telescopes and space missions, NASA has provided valuable data on the birth and life of stars. This knowledge helps scientists understand the processes that govern the universe. Stars go through several stages during their life cycles. They are born in nebulae, shine brightly during the main sequence phase, and eventually die in dramatic events like supernovae. By studying stars, we gain a deeper understanding of the universe and our place within it.